hope you're having a good day here. Quite informative and educational for all of us, I would say. I was just listening to the panel discussion previous to this, and a very good point brought up by Ankit. So he's talking about Zomato being an app, and like we see new features coming into it like every week or the week after. So that's the pace at which lots of applications are evolving. And even any sector that we are in, even with BFSI, our consumer-facing apps, the different kind of analytics that we do, that needs to change, that needs to transform day after day. Like every week, there could be releases of the new app, new versions. So the kind of experience that we want to have our customers to have on our platform, so connecting right to it, so how do we give that kind of experience? How do we make it better and better for our customers? We need to change and evolve our app, and underlying to the app, there's the database, the data platform that should be supporting your app. So my talk today is around the same, the data platform. MongoDB, as most of you would know, is a popular NoSQL database, modern database. And what do we bring to the table like with the data platform that we have, not just the database. Okay. So the agenda today for me would be to go ahead and introduce MongoDB to you as an organization as well, talk a very little bit about our product, and deeply look into where in BFSI segment, what kind of solutions do we offer, what are the solutions that are built on MongoDB. Okay. So just getting started, a quick introduction of MongoDB, our organization. So we have a clientele of 45,000 customers. These are the paying customers, not the community users that we have. So 45,000 plus paying customers to MongoDB. And we have 4,500 plus employees globally. And we are present in 140 plus countries. The graph that you look on the left side is the Forrester Wave quadrant. And MongoDB is at the leaders quadrant there in trans analytics. So trans analytics, again, is a new fad, which mainly means application analytics, like transaction analytics, and it's termed as trans analytics. What it means is that analytics is embedded into the transactions, and as we need our apps to be more responsive, we need to get that experience more real time. We get more trans analytics rather than doing analytics at the back end at a later stage. In terms of the clientele that we have, the MongoDB data platform for modern applications, so the clientele that we have in BFSI, that includes all kinds of like different banks globally, few of the largest ones. We have Goldman Sachs, we have HSBC. Even in India, we have few financial services and banks as our customers, and we are building on that clientele. Upstocks, ClearTax, Slice, Axis Bank, these are few Indian customers that we have. And Temenos is one of a global ISV. I'll be talking more about it at the later stage. So, as promised, I'll spend few minutes on the product that we have. And this is what we call as the data platform. So it's not just the database, it's an entire platform. And I would certainly want to tell you like why do we call it as a platform. So the core of the entire product is the document model. So a lot of us come from the relational world. We are used to storing data in rows and columns. And that brings in the rigidity that is there. Like when we want to make changes to this data, when our application has to add a new feature, there has to be a lot of changes to the database as well. I need to change the structure. I need to move my data from older structure to a newer structure. And that is where the document model comes into picture, which is completely flexible. You don't need to create a structure. You don't need to stick to a structure. It can adapt as on the fly. So document model is the core of it, which supports all different data models, such as key value pair, relational, tabular data, graph data, geospatial data. So I see a lot of use case of geospatial data these days. Some things like fraud detection in banking, where transactions might happen at two different locations from the same card. So that could be a geospatial use case, which we might use to work on. So all these data models align with document model. And then to access all of them, there's a unified interface, which is the MongoDB query language to interact with it. Now, on top of just the core database, we have various capabilities enabled. So these are something like search. So suppose you want to search from a customer's name, and you go ahead and misspell the name. So something called as a fuzzy search, autocomplete kind of use cases. So all of that is inbuilt using Apache Lucene engine. Then we have mobile application. So suppose you are building a mobile application that needs data from the core, from the backend. And we have something called as a Realm database, which is a mobile database. And in real time, it can sync data to the backend. It's a bidirectional sync, so data can travel both the ways. So that again enables a lots of use case that you can build on MongoDB using the mobile sync. So we have a serverless platform, and we have the first and I think the only NoSQL database supporting ACID transactions. So ACID like properties have fairly been related to like relational database, but 4 years back in MongoDB 4.4, we became ACID compliant, and we are fully supporting all kinds of transactions on MongoDB. So these are the different use cases that we support, different capabilities that we bring, and all of that on the backbone of like being resilient and elastic on the cloud, global and multi-cloud, and then secure. So security is again a prime value for us. So encryption in transit and at rest, field level encryption. So very often PII data needs to be encrypted at a field level. And we are at the forefront of cryptography right now. So we invested heavily in like building like security capabilities. And even field level encrypted data is right now searchable on our platform. So we are able to perform equality searches on that. So that's where the team is spending heavily like their time and effort. Okay. So all these as a platform, and then we enable different use cases such as anti-money laundering, account opening and balances, payment processing, lending use cases, loans and mortgages, customer 360 view, payment reconciliation. So all of these use cases are enabled on MongoDB. You can either like build it on your own, or there are different ISVs that we support that are there with us who have built these use cases on MongoDB. So the next few minutes I would want to spend on like modernization of application and what that journey looks like from a database standpoint. So how does the data infrastructure or data platform support that modernization journey? Okay. So this is the journey, the evolution that we see with many of our customers who come from a traditional background, and they have like maybe a core banking system which has been maybe on mainframes, or even larger data like Oracle and different databases. They have been there for some time. So the first step to that is offloading reads onto a different platform. So just offloading the reads, which is the basic ODS at the bottom, that itself starts giving you benefits in terms of cost and in terms of performance. And you can easily offload these reads onto MongoDB, and that can itself give you performance benefits. Now, once that scenario matures, you're gaining benefits of it, we go to a next stage where we can bring data from different databases, from different systems together. We can enrich it based on our business requirement and then present it to different applications. So that's the second stage of enriched ODL. Thirdly, we talk about parallel writes. So the write can happen on the core system as well as the new system, the data layer that we are building. So we are visualizing a core system that is used for all the core data, and then there is a data layer which gets the data from the core system, and then it is matured enough, it's maturing enough to get data directly from the transactions, and then it can be used for different use cases. So we'll be looking at the use cases post this. At the next stage, your ODL becomes the system of transaction. So writes happen directly on that, and most of your applications would be extracting data out of the system of transaction. That's the new ODL that is built on MongoDB. And lastly, at a final stage, your ODL will become the system of record, which will be the main system, and your original legacy system can be discarded at that point of time. Okay. So this is the journey of modernization. It's never at a rip and replace kind of stage. We slowly mature into what we are building, and we build that operational data layer called the OTL. Okay. So there are various use cases, various scenarios to see the benefits, like how we start using it. The first of it is data access layer. So what this means is that now we have the data in a different platform, in an ODL, and we can use it for different accesses. So suppose we are building a mobile app. So mobile app can take all the data from the ODL rather than disturbing the core system. If you have a website which provides the customer with different functionalities, so that can fetch data from your ODL. So that's the access layer. The second use case is as a data layer, as an operational layer. So all your internal operations, let's say you want a 360-degree view of your customer, what all interaction is he having with your bank. So all that can be fetched from a ODL. You can create a 360-degree view, which is a consolidated view of your customer interactions. So that's the second use case. And thirdly, it can be used for a lot of development purposes. We'll be looking at that in our next slides. Okay. So in terms of a data access layer, so I would want to talk about Temenos, which is an ISV for us. It's one of the largest core banking solutions. They have different solutions in banking industry. Core banking is the big one of them, which is called Transact. And they recently, they support banks across the globe, and they have a total access up to 1.2 billion people are doing banking through their application, which is around 30% of the total bank population. So they're that huge in size. They moved the core banking system. They're using MongoDB as part of it, and they stress tested MongoDB for the use case, and 150,000 transactions per second. So I'll just let that number sink in. So 150,000 transactions per second was something that they were able to achieve on MongoDB. And so the core banking application, the Transact app that I'm talking about, so it was 52%, like the TRP per core was 52% higher. Their app infrastructure was reduced. Their database infrastructure was reduced. And then the response time also has had huge improvements. So they are one of the ISVs that we work with, and they support like global banks, primarily across Europe and US as well. Few of the decision criteria for them, which we fairly stood well on, was like relational or document model, what works for them. And document model was what they went ahead with. Cloud native, cloud agnostic. So our platform is available on all the three cloud providers, the major cloud providers. And you can have the same running on-prem as well with equal capabilities. So suppose tomorrow either you have to move from on-prem to cloud, or maybe you want to move out of cloud and run on-prem. So you get the exact same capabilities, you can run it. Okay? Being an open source model that we have, like different NFRs that they were looking for, the RTO, RPO response times that they were looking for, we complied on that. Like different multi-region capabilities in terms of providing business continuity, HADR, all of that was compliant with us. Okay. So that was the data access that we were talking about. And then let's look at the data ODL for operations use case. So one of the primary use cases could be like payments, where you do reconciliation of payments across different systems. You could do a customer 360-degree view or a single view of customer, or there could be different processes. So suppose there's a trading platform, and trading happens at different applications, at different locations. So reconciliation of all of that into a single system to do some kind of reporting. So that also can be built on MongoDB. So let's have a deeper look at the payment system. So this is a payment 360-degree view. And as a full-fledged bank, there could be different systems handling payments. So there could be offline payments such as SWIFT or credit card transactions would be there. There could be real-time payments such as RTP or like NEFTs that we do. So all these different payments happen on different systems. Now when we talk about an end customer who is reaching out to their like customer success operator or to a support team, so they have to go ahead and search across different systems. Where did this transaction happen? What's the status of this transaction if there is some issue or some glitch in the system? So what we are trying to, what can be built is a consolidated view across all the systems. So this would be getting data from all different systems, such as mainframe systems, CRM, ERP systems, and then consolidating all of that across a single platform. One of the capabilities required for this platform would be the flexibility of schema, because different systems would have different, data in different format. And we do not want to get stuck with, okay, this format is not supported there, and like, how do I change and transform all of this? So the MongoDB platform will support all different kind of data formats. It can accommodate it. And then you build that single view of the payment or payment reconciliation platform on the MongoDB. So customer service agent has a single portal to operate. They don't have to look into different portals. Complaints can be served 24 hours across all different platforms that is required. 99.995%, 99.99% uptime, which MongoDB provides by distributed architecture, the 3-node architecture that we have, which is used for high availability and DR purposes. Okay, end-to-end monitoring of the payment status. The last use case is like in terms of development. So we talked about use and run. Build is the third part. So let's say you are on a journey to build a new customer-facing application where customer can get a view of their usage and all of it. So if you want to build, if you want to align your development team to it, they would require access to the data. But that itself is a big task, because you don't want to give them access to the core system. You'll have to see what accesses, what rights do you have to provide to them. That is where ODL comes into picture. ODL, it's easier to give access on that combined format of data. And using that, it's much easier to get your development team to ramp up and give them access to the production data. Okay. So that ends the ODL part. And another use case that I wanted to talk about was the fraud prevention use case, which is again involves a lot of AI and like data modeling, ML scenarios. So the simple architecture, the simplest that I could get, application sending data to MongoDB, the transactional data, all the interactions that are happening. And then we have things like chain streams, which can help you get real-time insights into the data. We have connectors with Spark, Kafka, and all, which can help you do analysis on that data in Spark. And through that, you can either connect to like triggers, do event-driven processings. You can send it to analytics or do visualizations on top of it, to send it to ML algorithms to do the analysis on that. So all of this can be done in real time. You don't have to like depend on like post-dated, delayed analytics. All this analytics can happen on the real time. So with that, covering the use cases that I want to address, just saying from Barclays' boss, calling out that banks have become museum of technology, because it's not because they are not innovative, it's because change is difficult. Moving from an older platform to a new platform is a risk, it's a challenge, and it's difficult. So that's what we bring to you, a powerful data platform which can cater to multiple use cases. You don't have to use different niche technologies to build your application. You can depend on one which provides so much that can be very useful for the application that you build in. So just leaving you with that thought. Thanks for your time.